Lesson 4.6, Rules of Exponents. The product of powers property says that when you multiply powers with the same base, you add their exponents. That's what's important in this property, that you add their exponent when you are multiplying powers. So for example, a to the n power times a to the nth power is a to the n plus n. Let's look at a number example. 4 to the 5th power times 4 to the 3rd. You see how it has the same base? Again, remember the base is the 4. This is the base. The 3 is called your exponent. The entire thing is called a power. So they have the same base, but the exponents are different. Because we're multiplying them, you can actually just keep the same base and add the exponents. 4 to the 8th power is your answer. X squared times x to the 8th power. Keep the same base, and we are adding 2 plus 8. 2 plus 8 is 10, so it's x to the 10th power. That's your answer. For example 2, remember that the problem is on the left-hand side. Now you can see that we have two different bases. We have a 2 and we have an x. So we're going to move it around so that the 2's are together. This 2 and 2 to the 4th are next to each other. And I'm going to put in parentheses just so I can clearly separate it from the other base, which is x cubed, which is this one, and x to the 4th, which is that one. And that's what they did over here. Okay. Remember, you can move numbers around when you're multiplying them. Now, because 2 to the 4th times 2. Remember this 2, any single number, like 2 or 6, has an exponent. It's this invisible 1. So there is a 1 there. So you actually have 2 to the 4 plus 1 power. And x is 3 plus 4. 4 plus 1 is 5, so it's 2 to the 5th. 3 plus 4 is 7, so it's x to the 7th. You can evaluate the power, which means to solve. 2 times 2 times 2 times 2 times 2. 2 to the 5th power is 32. The quotient of powers property says is that when you divide two powers with the same non-zero base, you subtract the exponents. So when you multiply, you add. When you divide, you subtract. So like a to the nth power divided by a to the n. This is a to the n minus n. Just like 6 to the 8th over 6 to the 6th, we have 8 minus 6. Keep the same base of 6, so it's 6 squared. Again, there is no need to solve this. We don't need to evaluate it. Just leave it as a power. For example 3, you're dividing, so we're going to subtract the exponents. Keep the base of x. 11 minus 3 is 8. So x to the 8th power is my answer. For b, we're dividing, so we subtract the exponents. 9 minus 6, which is 7 cubed. Go ahead and try 1 through 4. Remember, when you multiply powers, you want to add exponents. When you divide powers, you want to subtract exponents. Pause the video. Number 1, we have the same base m. We do 10 plus 5, which is 15. For number 2, keep the base 3. It's multiplication in between, so we add the exponents. 3 to the 9th power. Here we're dividing, so we keep the same base and we subtract the exponents. X to the 8th. For number 4, keep the same base and subtract the exponents. 8 to the 1st power. You could just write this as 8. You don't need that first power. Now we're going to simplify fractions with powers. Always start by simplifying the numerator or denominator first if there is multiplication. Remember, multiplication always, you're going to do that before you're going to divide, okay? Because it's like there's parentheses around this numerator. So we're going to add first. 6 plus 2 is t to the 8th. Now we got to get rid of our division. And remember, there's a 1 here. So 8 minus 1, keep the same base of t, which is t to the 7th. For example B, the numerator has different bases. M and n are different. What is the same, though, is the n to the 5th and the n to the 4th. So we're just going to subtract these two. Leave the m cubed where it is. Get rid of the division sign, because that's why we subtracted, to get rid of the division. And now we have m cubed and n, or n to the 1st. Again, you can put the 1 there, you don't need it. That's your answer. Go ahead and try 5 through 8. Remember, you're trying to make the problem smaller or easier to solve. If you're multiplying by the same base, you add. If you divide by the same base, you subtract. We're going to add first. There is this 1, so it's 8 to the 8th. And then we have to subtract, which 8 minus 4 is 8 to the 4th. Again, we add first. 5 plus 8, keep the 5. 5 plus 8 is 13. Then we subtract, just kind of bring that one over. Subtract, 13 minus 10 is 3. 5 to the 3rd power. There is no multiplication with same base. There is multiplication, but it's different bases. So the only thing I want to do here is divide. Keep the p where it starts, though. Because p's in the denominator, it stays in the denominator. What moves is the q, because 9 minus 3 is going to be q to the 6th power. Again, leave, because you don't do anything with the p, just leave it where it is, in the space where it is. For number 8, the x is in the numerator, so that's why we're going to leave it in the numerator. However, when I do 12 minus 5, that's also in the numerator. So there's nothing is in the denominator except 1, which we don't need. So you have x to the 12th power, y to the 7th.